now
Good
being
morning, good evening,
recorded.
everyone. Let's go ahead and start. Today, we'll focus mainly on LangChain Runnable. This is an important topic. We'll focus on LangChain Runnable. If you see in the last session, this is the code we have written to connect to the GPT models or Gemini models or Claude models based on the configuration. So in the configuration, we will specify what model we want. So do we want to use OpenAI models or Gemini models or Claude models? Based on this configuration, it will talk to that particular model and get the response and display it. This is the code we have seen. So here, what did we do first? You can recollect once. The first step is, okay, the first step is read environment variables or read variables from this env file. What is there in the env file? In the env file, we have environment variables related to the models. That means API key, model provider, model name, all those things are available. We have to read those. That is a line number. That is a line number 3 and 4. Once that is done, then we imported OS library. Why we are using this? Inside this, we have so many configurations, right? Which configuration we want to read? Let's say I want to read only model. I want to read only this. For that, we will use os.getEnv. os.getEnv and specify that particular key. For that purpose, we are using or we are importing OS. That is the second step. Okay. So if you recap the steps, these are the fixed steps here. Okay. Load environments. Okay, load environments, that is the step number 1. Then step number 2, import OS, and from that get env of specific key. Like that, you can specify whatever you want, os.get model, os.model provider, like that. Then step number 3, these are the fixed steps. Step number 3 is what? Initialize LLM means model. Initialize LLM means model. For that we are using what? For that we are using this method. For that we are using this particular method. So what this method will do? This method, the specialty of this method is, it will check what configurations are available in the environment variable. Based on that, it will try to initialize the model. Once model is initialized, then step number 4, we can invoke, okay, we can invoke the model by passing the, we can invoke the model by passing the prompt. So this is nothing but the prompt. This is nothing but the invoke method. What invoke method will do, we already discussed. So invoke is nothing but sending a request, sending a prompt request to the model. If the Gemini model, then Gemini model. If the Claude model, Claude model. So that's nothing but invoke, sending a request to the model. Sending a request to the model with what? With the prompt. So here we have given tell 2 best jokes, right? That's nothing but the prompt. That's nothing but the user input. Now, what exactly internally happens with the invoke method? So this is what we need to understand more. What exactly happens internally with the invoke method, or what invoke method will do? That is one of the interview question. What this will do? First, it creates a chat request because we are sending a request, right? It creates a chat request and so we are passing this question, right? So therefore sends HTTPS API request to what? To the model. Now model receives that particular request and create the and process that particular request. So request is nothing but what? Prompt. So the process the prompt, then generate the response. Then the return the response. That returned response is available where? In the AI messages. So therefore, if you run this, whatever is returned, I catched into RRRS response. Then in that RRRS response, there is a content I am printing. So if you just print this, you can see there is a AI message. These are all we covered already. Okay, now you can see AI message. So from the AI message, there is a content, that is what we are printing. From the AI messages, there is a content, that is what we are printing. So therefore, that is what exactly happens internally with the invoke method. So creates a request or create a prompt request, send a HTTPS request to the model, and model will take that prompt and process it, generate the response, then return the response into the AI messages. From the AI messages, there is a content, that is what we are going to display. This is what we have seen in the before sessions. Now the next thing is that what is runnable importance? Okay, why runnable, or what is the importance of this? Okay, importance of this. Why runnable, or what is the importance of this? That is the question. If you see, okay, if you see in this particular program, please observe here. If you see in this particular application, we have used many components. In this particular application, we used many components. What are those? In above application, okay, so we have many components used. What are the many components? What are the meaning of components here? For example, we have used model, that's nothing but LLM. Then we have used the prompt. Okay, we have used the prompt, we have used the LLMs, and we may use some functions, that is also we practice. Okay, we may use some tools, and so on, so on, so. So therefore, what I am trying to say is that if you take this application has lots of components. Okay, this application, okay, so we have many components in this application, or in this application we have many components. Please remember this. Please remember this. All these components are every component. Please understand this. So every component in LangChain. So these are all LangChain components, right? Every component in LangChain has its own style. Okay, has its own style. If you take the prompt, it has its own style and formatting. If you take the LLM, it has its own way of working. So if you take the prompt, it has its own style of formatting, right? If you take the LLM, it has its own way of predictions, generations. Okay, if you take the parsers, if you take the parsers, it has its own parsers. This also will study. So therefore, if we take application will have the models. Model, you can see we are already using. Application will have the prompts, functions, tools, parsers like this. So the point what you need to remember is these are all LangChain components, right? Every component has its own way of working, its own way of style. For example, if you take the prompt, it has its own way of formatting. If you take the models, it has its own way of predictions, generations, and all. So if you take the tools, it has its own way of how it functions. Parsers, it has its own way of doing the things. Now we need, okay, we need a common mechanism to bring all these things to one pipeline. We need common mechanism. Okay, we need a common mechanism to bring all these into one pipeline. All this into one pipeline, that's called runnable. That's it, that's it, that's it. So what runnable will do is this will connect all these components and bring into one pipeline. You don't need to do. So if you see here, we just passed the prompt to invoke method. We did not do anything. That means these are already connected. Why these are all connected? Because your invoke method is part of runnable. You can see here. Your invoke method is part of runnable. You can see here clearly. Okay, you can see here clearly. Your invoke method is part of runnable. That's it. That's it. That's it. Now let's recap one more time what is runnable. So if you take this diagram, I'll put this into the paint. Now you can see application. If you take application, so this is the application, right? So if you take application, there is a input, there is a output. Obviously, we are inputting something, we are getting the output. There is a input, output. In between, you have lots of components. There is a prompt component, LLM component, model component, parser component, like that. Like that. Now, all these functions or all these components has its own way of style. Prompt, yes, its own way. Models has its own way of doing the things. Now we need a mechanism to bring all these things into one pipeline. We need a mechanism to bring all these components into one pipeline. That's called runnable. That's called runnable. That's called runnable. So therefore, what is the meaning of runnable? So you can see here one more time, I am typing runnable. Runnable connects all kind of components. Connect all kind of components. What is the meaning of components? Models. Okay, prompts. You need to start remembering the terminologies. Models, prompts. So there are retrievers. We'll study all those things. Tools, parsers, functions. Like this, we have many components. Like this, we have many components. Runnable, connect all these components into a single pipeline. Single pipeline. That's the advantage. We don't need to remember too many things. You just use all these components. These are all connected because runnable. Why do we need a runnable? As I explained already, why do we need a runnable? Why? What is the importance of runnable? Why do we need a runnable? What is the importance of runnable? As I mentioned, all these components, all these long chain components like prompts, models, all these long chain components has its own way of style. Now we need a mechanism. We need a mechanism. We need something which will bring all these things into one rope. That is one pipeline. That's a runnable. Okay. Now, if you see here, the invoke method, whatever we are using is part of runnable. You can see here, if you open this, how do we do this? You can go to this particular method, control click or control click. When you do the control click, you will get like this. There is a runnable. Click on that. Control click again. Once you do the control click, now it opens. Now you can see here line number 125. Runnable is the class which has the methods. Invoke method, a invoke method. Invoke method is nothing but whatever we studied. A invoke is asynchronous. We'll practice all these things today. Then there is a batch method. Okay, there is a batch method, stream method, a stream method. Like this, we have multiple methods part of this particular runnable class. So therefore, whatever we have used, invoke is part of runnable. Whatever we have used is part of runnable. Therefore, the conclusion is LangChain team introduced runnable with LangChain team introduced runnable with three main methods. Sorry. So what I'm trying to say that, so if you take these components has its own way of styling working, right? working. So to resolve those issues or to bring all these things into one rope, one pipeline, we are using in a Runnable. Runnable has mainly three methods. Okay, what are the three methods? Just now I put in the above screenshot. You can see. You can also see here. So there is a invoke method, which is a synchronous, and for asynchronous, there is a invoke method. So there is a synchronous and asynchronous. We'll practice this. There is a batch method and there is a batch method. Synchronous, asynchronous. There is a stream method and there is a asynchronous stream method. We'll practice all these things. So therefore, Runnable is the class which provides or Runnable bring all these different component styles into one rope, one pipeline. That's the advantage. So inside the Runnable, we have mainly three methods: above, invoke method, batch method, stream method, which is synchronous methods. For asynchronous also, we have a invoke, a batch, and a stream. So in a simple word, a invoke method is nothing but asynchronous version of invoke method. That's it. Then a batch method is nothing but, this is a simple way of understanding. Okay, asynchronous version of batch method. Then a stream method is nothing but asynchronous version of stream method. Then we need to understand a question. Now our next question is, what is synchronous? What is asynchronous? What is synchronous? What is asynchronous? Synchronous means, let's say we have two parties. This is the best example to understand. Let's say you are here. Okay, I am here. This is you. Okay, this is you and this is me. This is you and this is me. You dialed my number. You dialed my number. I am available. If I am available, what we will do? We talk each other. You dialed my number. I am available. We talk each other. That's a synchronous. So therefore, in case of synchronous, both should be active. Both should be active. Then what is the meaning of asynchronous? Asynchronous means what? Let's say you are here. Okay, I am here. This is you. This is me. Okay, so you dialed my number. You dialed my number. I am not available. You dialed my number. I am not available. Then what you will do? You will drop the message to me. Okay. You drop the message to me. Once I back, I will do my work. That means I will do on my own way. Both no need to be available at the same time. Synchronous means wait. So let's say I have something. If I want to do it, I have to wait for you. If I want to finish my task, I need to wait for you. Asynchronous means I will do my task, you do your task. I will do my task, you do your task. That's a asynchronous. Synchronous versus asynchronous. That's it. That's a simple example. You dialed my number. I am available. Here two parties are there. You, me. I am available. We talk each other. Synchronous. So that means to finish my task, I need to depend on you. Okay. Then asynchronous means what? I have a task. I give to you. If you are busy, yes, you can do it whenever. But I will not wait. I will start one more thing. So right now, whatever we are doing is asynchronous. You can you can also see you are listening and writing. You are listening and writing, kind of asynchronous. Synchronous means only one task. Asynchronous means you can do multiple things also. That's the meaning of synchronous and asynchronous. These terminologies we are using for a long. That's why. So asynchronous is nothing but a invoke is nothing but A invoke is nothing but asynchronous version of synchronous, or sorry. A invoke is nothing but asynchronous version of invoke. A batch is nothing but asynchronous version of batch method. A stream is nothing but asynchronous version of stream. All those things we will learn one by one. We will practice one by one. Before we go further, let's see the notes. So you don't need to type anything. You just listen here. Okay. You just listen here and remember as much as possible. I will provide all these notes for you, everything. As I said, we are trying to understand the runnable. So if you take this application has many components like models, prompts, retrievers and all. It's a time to bring all these things to one pipeline. That's nothing but runnable. That's nothing but runnable. As I mentioned, you do control click, then it will come runnable. Then you do control click, then it will show all the corresponding methods. It's not only methods here. This is the methods, right? If you come down. This is how you can see the help also. If you come down, you can see that methods, what kind of things it is doing, and example coding. All these things it will show you. So you can see here runnable. Okay, runnable is providing the methods, and also you can see here runnable is providing like runnable is providing this compositions. Okay, what are the meaning of compositions? Like runnable sequence, runnable parallel, all those things also it is providing. Runnable sequence. So that means going forward, you are using a invoke, a batch, a stream, parallel sequence, runnable, runnable sequence, runnable parallel. These are all part of runnable. That is what you need to understand. We'll practice this runnable sequence, runnable parallel, all those things. Now you can see this simple examples also here. Runnable sequence example. There is a one more thing called a runnable lambda. Runnable sequence, runnable lambda. Like this, it provides lots of compositions. Runnable sequence, runnable parallel, runnable batch, runnable lambda. You can see here. Okay, so now if you want to understand these things, you can practice these simple examples, or you can write your own examples also. Okay, there are so many things here. How it is given, what kind of help, examples inside the coding, everything is available in this. This is the Python, this is the library basically, runnable library. That's it, that's it. So that's why you can see here, runnable takes the input and generate the output. Runnable take the input and generate the output. That's it, that's it. Now this is what I told already. Why runnables are introduced. You take LangChain components, every component has its own style, how the prompts works, how the models works, then how the parsers work, how the chains works, like that. Now we need a mechanism which will bring all these things to one root. For that, LangChain team introduced to resolve all these things with the three methods: invoke method, stream method, and a batch method. And LangChain also provides several built-in runnable types, task-specific runnable types, and runnable primitives. What is the runnable primitives? Just now I told runnable primitives, like a runnable sequence, runnable parallel, runnable sequence, runnable parallel. All those things are runnable primitives. So if anyone asks a question, can you explain runnable primitives? Runnable sequence, runnable parallel, runnable batch, runnable lambda. Like that you need to tell. If anyone asks task-specific runnables. Task-specific runnables means call the LLM, take the prompts, all those things. Those are nothing but methods. Those are nothing but methods. Like this, runnables are providing, or runnables are divided into two parts: task-specific runnables, runnable primitives. Runnable primitives are nothing but runnable sequence, runnable parallel, runnable batch, runnable lambda, all those things. Task-specific means like calling the LLMs, that prompts, Okay, receiving the documents like these methods. That's it. Like these methods. That's it. That is what we understood, and that is what we have. Now, let's exercise these methods. So the first one is invoke method. The first one is invoke method. Invoke method we already practiced enough, but let's do one more time. Invoke method we practiced already enough. Let's do one more time. I'll just close this help. I will take this and paste it. I don't want to write one more time everything. I just pasted our yesterday's application. First one is what? We are trying to load the environment. We are trying to load the variables from .env. That is the line number 3 and 4. Then we imported the OS. Once we imported the OS, we need this init chart model. What is the purpose of this init chart model? That is the one, okay, init chart model. That is the one which will go and see what is available in the environ.env file and load the, okay, load the models dynamically, identify the models dynamically, initialize the models dynamically, initialize the models dynamically. That's it. Okay. Okay, that's it. Then we are trying to initialize the models with the by passing my model provider and the temperature. That's it. Temperature is the optional that we already discussed enough about the temperature. Next, I want to invoke it. So you can do the invoke method. This is what we practiced already. And I want to display the response, we display. This is how invoke works. This is how invoke works. So therefore, when to use invoke or when to use, this is the question. When to use invoke? We have invoke. Now we need to understand this. We have invoke, we have batch, we have stream, right? Now it's time to understand when to use this. Invoke is very simple. We already used it yesterday, but only thing is that we need to study it. That's the same example for invoke. So when to use invoke? When we have one prompt, then go with invoke method. So right now, if you see in the current example, I have only one prompt, right? And one response. When one response for one prompt, then go with the invoke method. One response, one prompt. So this is nothing but the prompt. Tell about or tell me two best jokes. That is nothing but the prompt. That is giving one response. One prompt, one response. Then go with the invoke method. So that means one prompt, one response. One prompt, one response. That's why you can see here. So one prompt, one response. Response is nothing but output. Then go with the invoke method. So that's what we have seen. That is the example of this. Then the next question is, what happens if I want to if I have multiple prompts? What happens if I have bulk prompts? Then we need to go with the batch. We need to go with the batch. So batch is nothing but what? N number of prompts. Here one prompt, right? Here n prompts. Then what about output? What about the output? Am I going to have one output or multiple outputs? Am I going to have one output or multiple outputs? N outputs, n responses. Then we go with the batch. Let's see the example. So we need to, in the previous example, we had only one prompt. Now we can have multiple prompts. Let's go here. Okay, I will just try to modify whatever we have. Anyway, we understood the invoke. Now I want to use the batch. Okay, that is also part of Runnable. That is also part of runnable. That is also part of runnable, right? Now, let's create a prompt that has multiple. For example, so right now this is the prompt, right? Tell about or tell two best jokes. That is the prompt in the previous example. Now I'll create a new prompt. So let's say RRRS underscore prompt. These are just names, okay? Left side are just names. There is no specific meaning. RRRS prompts equal to now prompt 1. Explain AI in one line. That is the prompt 1, comma. Multiple prompts, right? In the previous example, only one prompt. Now we have n number of prompts. If we have multiple prompts, we have n number of prompts. We have batch prompts. Okay. We want to process multiple prompts. We want to process batch prompts. Then go with the batch. Bulk prompts. Then go with the batch. Why we need to go with this? Because it allows simultaneous executions, which improve the performance. Instead of executing one by one, it will do simultaneous executions, which will improve the performance. Right. So my prompt is explain AI in one line. That is one prompt. Then explain data science in one line. That is another prompt. I have three prompts here. Okay. Explain Python. Explain in one line. This is another prompt. So if you see here, I have three prompts. I can go individually also. If I go with invoke, then it has to wait. Okay, invoke with the prompt 1, invoke with the prompt 2, invoke with the prompt 3. Assume that one prompt is taking 1 minute, then invoke requires 3 minutes. But if I go with a batch, it will do simultaneously. So it will improve the performance. That means it will do parallel mechanism. That means what I'm trying to say is that, so let's say if I go with the invoke method, invoke prompt 1, okay, invoke prompt 2. So we are discussing batch, right? Let's say we have three prompts right now, prompt 1, prompt 2, prompt 3. If you go with the invoke method, invoke of prompt 1, invoke of prompt 2, invoke of prompt 3. Like this, we go with the three prompts, individual prompts. Then it's a synchronous, right? It's a synchronous. So therefore, one after another. Assume that one prompt is taking 1 minute to process, then 3 minutes. That's the problem. That's the challenge if you go with the invoke method. So that's why when you have multiple prompts, bulk prompts, then go with the batch. So what I will do is batch of prompt 1, okay, prompt 2, prompt 3. I'll pass all. Then all these get processed. All these get processed simultaneously or parallelly. Simultaneously and parallelly, which may end up even 1 minute, 1 minute plus, or 1 minute little bit more, maybe 1 minute 10 seconds like that, which will improve the performance because it will execute parallelly. Okay, so that's the advantage of batch. Now let's go to here. Line number 17. I have three prompts right now: prompt 1, prompt 2, prompt 3. Okay. Now instead of invoke method, I am using batch method and pass those prompts. Okay, pass those prompts. That's it. Now run this. Now run this. Now we have three prompts, right? Three requests are going. What happened? RRRS content. RRRS. Okay. So here one more point. Yeah. Here one more point. Please see this. In case of invoke method, in case of invoke method, you can see here, we have written already. In case of invoke method, one prompt, one response. Here, n prompts, n responses. As we got n responses, it is a list you can see here. It is clearly telling, hey, you are getting a response of list. You should not print like that. So that's why line number 21 is wrong. This is good for invoke method because one request, one response. Here multiple requests, multiple responses. So therefore the return is nothing but the list. When you have a list, obviously you need to iterate it. Obviously you need to iterate it. So how do I iterate? By using loops. Let's say for loop, for response, okay, response in where this RRRS response. Okay, so that means what is the meaning? What is the meaning? The meaning is from RRRS response, take one by one. If you have three responses, take first response, take second response, take third response. From that response, you need to print the content. From this response, you need to print the content. That's it. Now execute it and see it should work. Now execute it and see it should work. See, it is working. Please observe here, it is working. So here we have three prompts. Three prompts means three responses. That's the difference here. You can see the if anyone asks, can you explain difference between invoke and batch, or when to go with invoke, when to go with batch. If one prompt, one response, then go with invoke. If you have n prompts, n responses, then go with batch. Why I need to go with a batch if n prompts and n responses? Because it will do the parallel mechanism. It will execute parallelly. It will execute simultaneously, which improve the performance a lot. That's it. So that's why the return type is nothing but the list. So when you have the list, you need to take one by one and display it. Take one by one means loops. From this response, take first one and display the content. That's nothing but the AI. Next, the second one is what? Data science, right? Take the second one and display the content. See here. Then take the third one. Third one is nothing but Python. Take the third one and display its content. Now it's giving about Python. That's it. So n prompts, n responses. That's where write the loops, iterate it, get one by one, and the display of content. So the first one is explain AI. That's the response we are getting. Second one is explain data science. That's the response we are getting. Third one is explain Python. That's the response we are getting. That's about this one. Then there is one more method called generate method. Okay, there is one more method called the generate method. Okay, now let me show you the nodes for invoke method and batch method. So you have a clear nodes here. As I said, explain invoke method. When one response for one prompt, then go with the invoke method. And this is the program we have written. Now you can see the flow. You can see the flow, please. You can also write human messages, all those things if you want. You can also write like this. Yeah. Okay. So you have written the human message that is passed to the invoke method. You can see the flow here. Let me take this into the paint. If you want to understand this way also, you can understand the flow. First, what is happening? You have written the message. That's nothing but the human message. Message types we already studied. If you are simply writing like this, then it's a human message. We understood already. Line number 16. Here you have the prompt. That's nothing but the human message. That's good. That human message you are passing to the invoke method. That human message you are passing to the invoke method. That internally converts that creates the chart model. Next, that creates the chart model. After that, you have LangChain provided adapters, which will convert this into equivalent models. We already exercised this. Then call the APIs. Then this request get processed. Generate the AI response. That AI response is available in the AI messages. In the AI messages, there is a content. That's why we are displaying that content. That's it. Now, if anyone asks a question, when to use invoke method? Single question, single response. No streaming needed, no asynchronous needed, no common LangChain execution patterns. Then go with the invoke method. That's it. This is how you have the nodes clearly. Then batch method. Just now I told n request, n responses, go with the batch method. Okay, n request, n responses, go with the batch method. You can see here, please. You can see here, please. This is also differences you can see. Invoke method, one request, one response, and AI message. But in case of batch, it is a list. In case of batch, it is a list. N methods, n prompts, n responses, it is a list. So here single prompt, here bulk prompts. Then one question, 100 questions. Like that, you can also see the differences. Whatever we studied, I just put it as a question and answer. So if anyone asks differences between invoke method and batch method, then you can tell that one request, n request. One output, n outputs. Here it is a single response, AI message, list of AI messages. Then single prompt, bulk prompts. Throughput, lesser or higher, because it's a parallel mechanism, simultaneous mechanism. When you have one question, go with this. When you have 100 questions, go with this. Okay, so this is the program we have written. Now you can see the execution flow. This is the program we have written. This is the application we have written. So therefore, application gets started. Then we have a environment variables. Application gets started. Then we have a environment variables. Load environment variables. Okay, or load.env file configurations. After that, we have model provider. Okay, we have model provider. This is the internal steps. And then we have initialize model. Creates the model. If it is a Gemini, Gemini model. If it is a OpenAI, GPT model, like that. Once that is done, then there is a prompt here. There is a prompt here. Create the prompt. Then you are trying with that prompt, you are trying to invoke the batch method. Now here we have three prompts, right? So all these three prompts get processed parallelly. You can see there is a prompt 1, prompt 2, prompt 3 parallelly, simultaneously. That is the advantage of batch method, which will improve the performance. And for prompt 1, you are getting one response. You can see. For prompt 2, you are getting one response. For prompt 3, you are getting one response. So that's why response 1, response 2, response 3. All these are kept into the AI message list. All these are kept into the AI message list. As it is a list, write the for loop. Write the for loop. Get one by one and display it. Get one by one and display it. This is the flow. Get it one by one and display it. So whatever I discussed, it is explained neatly with the diagram here. That's about the invoke method and the batch method. Then there is a generate method. There is a generate method. Let's see what the specialty of the generate method. The specialty of the generate method is generate method do similar, but it has more information. It has more metadata in the output. Okay. Generate method use when we need multiple generations. Multiple generations. What is the meaning of multiple generations? You need the structured output, you need the output, and you need some report related information. That means metadata. Okay, metadata. We'll see the example. Then go with the generate method. Use generate method when we need multiple generations. It's not a single generation, multiple generations. What is the meaning of multiple generation? You need the structured data, you need the metadata, you need some kind of report information. Then go with the generate method. In the real time, this is the best one. In the real time, this is the best one. Let's see one example with this. Let's see one example with this. Let's see invoke method first. Let's see invoke method first. Here we created the model, then invoke method, right? Invoke method, if you do like this, internally it is a human message, right? Internally it is a human message, right? Or the same line you can write like this also. RRRS response equal to LLM RRRS LLM dot invoke method. Same thing you can write like this also. Invoke method, and you can pass that messages. Invoke method, you can pass that messages. Which message? Human message. Okay, human message. We need to import that also. We did not import, right? Okay, let's import from where you want to import, from LangChain dot messages, and what you want to import, human message. For now, human message. Okay, human message, and that will have a content, right? Content equal to tell two best jokes. Tell me two best jokes. Like this you can write. Same thing here. So if you write the line number 17, if you write 18 to 20, both are same. So this is internally human message only. This is internally human message only. So if you delete this, execute it, you will get the same response. If you delete it and execute it, you will get the same response. That's good. Now what I'm trying to say that instead of printing the content, let me print just response. Let me print just response. Okay, response got printed. Now let me take this response into, this is invoke method response. This is the invoke method response. Okay, invoke method response. We got the response, and that is the response. Okay, good. We got the response and we displayed the response. Now there is a generate method, right? Let me do same thing with the generate method. Instead of invoke method, let me use the generate method. Instead of invoke method, or let me do one thing. Let this be as is, and I'll copy this, paste into the next cell. So instead of invoke, I'll use the generate. Instead of invoke, I'll use the generate. Now execute this and see. Now execute this and see. And one more thing is that this is a tuple. Okay, so that means you need to pass this as a tuple, not a normal one like this. Invoke method is just taking a parameter as human message, but this is going to take tuple. Tuple means multiple things, and just run it and see. Okay, now you got the response. Okay, what is the difference between invoke method and this one? Invoke method will take one input, right? One input, but this is multiple inputs also. How it will take multiple inputs? As a tuple. That's why if I don't use that bracket, we are getting an error, and you can see the error also. It is important for you to read the error and understand. So tuple object has no attribute called content. So it is not recognizing the content. So that's why keep this here. Okay, now run it, you will get the output. Now you got the output, right? Now, if you see the output, that is the invoke method output. This is the generate method output. See, is it having more information than this? Same question, right? Please see this. If you see this, here generate method. I just executed, you are getting this. And I took that sorry, this is the generate method. I executed and putting the response here for easy understanding. Now, the same thing I am doing with the invoke method, executed and put the response here. Now, if you see here, generate method, that's what I told. Generate method used to generate multiple generations. What the meaning of multiple generation? Structured output, report, metadata, all those things. Now let's see whether we have the metadata. If we take the invoke method, it is having the response. You can see it is having the response. Good. Here also we are having the response. Here also we are having the response. Here also we are having the response. Now you can see resource metadata. After this, okay, now you can see resource metadata. AI message. You can see here, please understand. Here. Okay, so here AI message, that has the content. You can look at the difference. So this is this one. Let me take into the paint maybe, so that I can highlight it. It has more information. That's it. What that information? If you need that kind of information, go with the generate. Generally, we need that kind of information. That's why in the real time, we use this generate method. So if I use the invoke method, this is the one we got it. And here also we got it. No problem. Okay, no problem. Now, if you see here, in the invoke method, so you have a metadata. Here also we have a metadata. Okay, here also we have a metadata up to this. You can see here 1, 2, 3 cache read. 1, 2, 3 cache read. Yeah, till this. Then after that you have a extra information. You can see in case of a generate, this is the extra information. This is the extra information which is telling that how it is generated, all those things. And there is extra information here. I'm just putting a different color. For extra information, I am putting different color here. This is the extra information we have. This is the extra information we have. That's it. So that means type equal to LLM results. Then you can see there is a reason token, okay, completion token. That kind of report also generated. Okay, audio tokens, cached tokens. These are all not there here. Okay, there is a extra information. So if you want to use this kind of extra information, for example, there is a ID. For example, there is a ID. So here you don't find ID, right? No, ID is here. You can compare here, or let's do one thing. Let's go to the comparator. Text compare quickly online. Okay. What I will do with that, you can see what is the difference. That's it. That is the easiest one, right? Let's go here. I will take the response generated by invoke method in the left side. Next, I will take the response generated by generate method in the right side. Now find the difference. Now you can see there is a lots of difference. Okay, this green colored one are not available here. The green colored one are not available here. Okay, so in the green colored one you can see there is a complete token details accepted like that. So many things are additional. So that's why I said go with the generate method when we want multiple generations like a structured output, report, metadata, all those things. Then go with this. That's it. That's it. That's it. And as I mentioned, right, one more thing between here only one input, only one prompt. Here we can have multiple prompts also. It is a tuple. So you can use comma. Sorry, you can use comma and specify one more. Let's say explain AI. Okay, tell or explain AI in one line. Explain AI in one line. And similarly, you can put one more prompt also. Like this, multiple prompts also you can have with the generate method. Explain data science in one line. Like that, you can do it. That should also fine. But the end of the conclusion is generate method generates it. Okay, structured output with multiple things. This mainly we use in the real time. That's it. That's it about the generate method. So now if you see our nodes also, this is what I mentioned. Okay. This is what our program. So it will start the program. So this is the flow. Start the program, load the environments. Then model provider creates the model, create the model. After that, we have a conversations. These are nothing but the conversations and a conversation list one, list two, list three, like that. We have multiple. You can pass single or you have multiple. All these things are passed to the generate method. Now generate method call the API. Now generate the responses. Generate the response for first one, generate the response for second one, generate the response for third one, and all are coming and we are displaying here. All are coming and we are displaying here. That's it. That's it. That's it. And one more point is that, please remember, one more point is that if you see here, when I run this, when I run the generate method, it has the content. Okay, it has the content and it has the generation. You can also print the generation. That is the extra you have, right? So RRRS response dot generations. That is the extra you have. That will tell what exactly it generated extra. You can see. So it has the stops, nones, all those things. Messages. That's it. That's it. It has a content, message, all those things. You can see here. Generations. Messages. Message is nothing but AI message. Within the AI message, you have the content. That content is same as this one. That's it. That's it about generate method. Now let's move on to the next one. Let's move on to the next one. All these methods are important because these are used heavily. As I mentioned, if you see the notes, right? So explain generate method. It generates multiple things, metadata, report, all those things. Best to use in the real time. And this is the flow. You got the results. Results has the generation. There is a little difference between invoke method and this one, right? So that is the difference. Results, your results has generation. So that has a first generation, second generation, all those things. And you have a LLM output, you have a metadata, all those things. That's it. This is how you get the nodes. And if you want to practice the example also, This is how I will be sharing the code. Don't worry about how to type this code from the screenshot. If you want to type the code or if you want to practice it, you can take this and practice it. If you type from screenshot, it is excellent because you are learning a lot. But if you don't have that much of time, you can copy this and execute it, it will work. All right, the next method is stream method, right? So we completed invoke method, we completed batch method, we completed generate method, and there is a stream method. Okay, stream method. So what is the meaning of stream? As I told, if you go to the ChatGPT or platform OpenAI, if you go to the ChatGPT or ChatGPT is also fine. ChatGPT is also fine. Go to the ChatGPT and type explain AI. Type explain AI. Now you can see there is a big response. When there is a big response, you will see it's coming like a token by token. You can see there is a spinning. Output is spinning to me. That means when you have a big response, even in the before session also we covered asynchronous API calls. You need to compare with the streaming response. Yes, we studied 10th session. In the 10th session, I explained stream response. The same concept here. If there is no stream, okay, if there is no stream, what is happening? You are sending a request and the response is big, then you have to wait for the complete response. That means customer may see some blank screen. Let's say you are going with the invoke method here. You can type, let's see, STREAM, STREAM, stream method we are discussing. Let's say we are going with the invoke method. You input something to invoke method, then it has lots of response. It generated big response. If it is generating big response, then customer may see some blank screen. Okay, blank screen to get output. Customer may see some blank screen to get output. That's what we discussed, right? In the 10th session, this is what we discussed, streaming response. Streaming response. That's why if you see the flow also, when if there is no streaming response, if there is no stream equal to false, then we send a request. There is a big response. Then you have to wait for that response. You have to wait for the response. Here, customer may see some blank screen. Then in case of stream, you send the request. When there is a big response, you get the response as chunks, like a chat GPT style. Like a chat GPT style. You can see, tell about Python. You can see there is a big response. If you see the output, you can see it is adding output to me one by one. That means chunk by chunk. So if you want that chunk by chunk, same as 10th session streaming response. So you send a request, then there's a big response, then you will get the response as chunks, like a ChatGPT style. If you want that, then go with the stream method. If you want that, then go with the stream method. Now please observe here. Please observe here. So we have a invoke method, right? This is the invoke method. Let me take this and paste one more time. Now instead of invoke method, I am using stream method. Okay, and I will say tell about Python or tell 23 jokes. Tell 23 jokes, best jokes. I just use the number more so that you can see the difference. Please observe the output. You can see it's keep on increasing. Can you see this one, please? I am just running. You can see. Okay. One more point is that here we printed the object, right? That's why you are not able to see the difference. You printed the object. That's why you are not able to see the difference. Let's print the chunks. Then you will see. Okay, all right. Now if you see here, LLM.stream, models.stream, then tell 23 best jokes. That's what I said, right? That is going to give the response. From that response, you need to take the chunks and display it because it has lots of chunks. What we can do is that we can also write the loop here for okay for we will get the chunks, right? Let's say RRRS, and these are just names, so that's why you can use it. Will give the chunks. That response is nothing but the chunks. I will take this, colon, then I need to print it, right? So print that chunk dot content. Print chunk.content, and you can say new line, end every time. Okay, that's it. Now let me remove this for now. We don't need that line. Okay, now please observe here. Now I am trying to use the stream method, and I said tell 23 best jokes. It is a big response, right? Now response will come chunk by chunk. So I can take chunk by chunk and display it. Please observe here. Now you can see it's adding. Yeah, you can see. Are you able to observe? That's called streaming. Instead of wait for the big response with the blank screen, get chunk by chunk. This is the best understanding. I'm running one more time, you can see. I just ran. So you can see first response, first chunk, second chunk, third chunk, 10th chunk, 13th chunk, 14th chunk, 16th chunk, 23rd chunk. So chunk by chunk it is coming and displaying. That's the advantage of the stream. So therefore, when to go with the streams? Real-time token streaming. When we want a response token by token, chunk by chunk, ChatGPT style. When to go with? When we want response token by token. When we want response token by token or chunk by chunk. When you want chunk by chunk, or when you want a response like a ChatGPT style typing, then go with the streaming. I am running one more time, please see this. Okay, I just ran. Now 23 best jokes, right? First one, first chunk, second chunk, third chunk, 13th chunk, 15th chunk. It's keep coming. That's about the streaming. Okay, now let's see the notes, please. Let's see the notes. Streaming, as I explained, this is the example. That is what you can see. Now the difference between invoke method, batch method, generate method, stream method. There is a predict method. It is a legacy. We don't need to worry about this. If anyone asks what is a predict method, you can say it is a deprecated. We don't need. That's it. So then these are the differences we discussed and we demonstrated also. But for interview purpose, you need to remember this screenshot. That's it. So therefore, now let's go back to our beginning of the discussions. We have invoke method, batch method, stream method. Equivalently, we have a invoke, a batch, a stream, which is nothing but asynchronous version of invoke, asynchronous version of batch, asynchronous version of stream. Now let's do some practice on those. This is the thing here. You can see here. So a invoke is asynchronous version of invoke. A batch is asynchronous version of batch. A stream is asynchronous version of stream. And the remaining is same: single prompt, multiple prompts, single prompt, multiple prompts. Okay, then if it is a single prompt, go with the invoke method. Multiple prompts, bulk method, like the batch method, right? It's asynchronous. Don't wait for it. It will process it. Asynchronous version. Don't wait for it. It will process it. That's what it is. Now, if you want to see one example, let's see one example for the asynchronous methods. Okay. So let's go here. Let's go here. And I will take this. Okay. I'll take this and copy one more time so that I can do the modifications. So we need to load the or read the variables from environment variable, load it, all those things. This is required, this is required. Human message, for now we can give directly. Okay, not required. Then initialize the LLM. Okay, initialize the model, that is also required. Then invoke method. First, we have seen the invoke method. Now a invoke method, asynchronous. Okay, asynchronous. Let's practice it. What I will do is that, so we get the response with the invoke method and we pass it that directly, right? Like this, tell two best jokes. Okay, first run the invoke method once. We are getting the response. Yes, we are getting the response, no problem. We are getting the response, no problem. This is also not required here. That is required initially. Now we want a invoke, right? A invoke, asynchronous invoke. For that, what you need to do is that we need to tell that this method is asynchronous. ASYNC, asynchronous definition, main method. Okay. Then inside that you write this asynchronous method. That is giving the response. Then print the response. RRRS response dot content. Like this, you can print it. Then this is the asynchronous method, right? So you need to wait for it. So there is a await this asynchronous method. That's it. That is how you can call it. So what happened? Why we are getting error? You can read it. There is a object content. There is a spelling mistake. Content. That is correct. Okay. Asynchronous. ASYNC. ASYNC. Spelling mistake. Asynchronous definition. Main method. Then RRRS response. Okay. Equal to, here you need to use await. Yeah, it's telling wait, use await. Okay, now run this. Okay, we should get the output. Yeah, you can see. So that means what? It will submit the request. Don't wait for the response. It will submit the request. Don't wait for the response. That's called asynchronous. That's called asynchronous. In the beginning, we discussed. That's it. So instead of using way invoke method, it's a invoke method, asynchronous invoke method. Like this, you can do it. Then we have a batch method, right? A batch method. Okay, a invoke method is done. Then a batch method. So what it will do? Similarly, you can just copy this once. Okay, when we have multiple requests, we are going with the batch, right? So here also same. Okay, here also same. Go and create multiple requests. So let's say RRRS underscore PROMT equal to, you can create multiple requests, explain AI in one line. Why I am giving one line here? If you don't give one line, then it will give lots of output. Lots of output increases the tokens. Increases the token is nothing but increases the cost. Explain data science in one line. Like this, you can give multiple prompts. You can give multiple prompts. And now I don't want this A batch. For that, you can pass your prompts. All the prompts you can pass. And you will get the response. That response is a list, right? That's why you need to write the for loop. Okay, for response in RRRS response. Okay, in RRRS response. Okay, from that take one by one and display it. Take one by one and display it. Now execute it. See, you are getting. Okay, list object has no attribute called content. List object has no attribute called content. So if you see here, so main method that is done, then prompts, yes, we are good. Response equal to await of batch method of a batch of these prompts, that's correct. Okay, that is correct. Then we have written the for loop and taking from the responses and printing response dot content. Okay, execute it. Now you can see, can you see this one place? It's doing asynchronous, submitting first one, submitting second one, like that, and getting the responses. Similarly, we can use the streams, asynchronous streams. Okay, a stream. Okay, a stream. Let me copy this and paste it. Okay, now instead of a invoke, I will use a stream. That's it. That's it. Then it is going to give the chunk, right? That chunk you need to display it. Okay, it is going to give the chunks. That chunks you need to display it. So that's why you need to write the loop. So this, instead of this, you can say async asynchronous for loop chu. This is just a name, right? You can say RRRS underscore chunk chunks in this LLM dot stream. So that will generate that will give the chunks. From that chunks, you need to display it. From that chunks, you need to display the content. And you want new lines, end equal to, just to put this. That's it. Now execute this. Okay, now that is done. Now you can see asynchronous. Let me use here 23 base hooks. 23 base hooks. Okay, now first one, asynchronous invoke is done. Second one, asynchronous batch is done. Now third one, you can see. Before I scroll, all are done. Let me do one more thing. Okay, now you can see asynchronously. Earlier you see, yeah, you can see coming as a chunk. Coming as a chunk. That's about the asynchronous methods. Asynchronous stream method coming as a string. That's about all these methods. We will be using these methods heavily. That's why it is important for you to understand all these methods clearly. That's it. Now you can see the notes. Once we discuss Runnable, what is the importance of the Runnable, and Runnable provides two types of categories, built-in categories. One is task specific and runnable primitives. Runnable primitives are nothing but runnable sequence, runnable parallel, runnable batch, all those things. primitives are base specifics, task specifics are nothing but invoke, stream, batch, all those things. Then we have seen the exercise for invoke method, batch method, generate method, then stream method. Stream method means chunk by chunk. Then we have asynchronous methods, a batch, a invoke, a stream, and this is the exercise for it. That's it. That's it. All these things. And you can see the nodes. You can see how that asynchronous, okay, asynchronous stream method. So you can see that a invoke method also asynchronous. So if you want to use asynchronous, you can gather this and use it. There is one more conclusion here. There is one more conclusion. There is a invoke method, a invoke method, right? A invoke method is applied with the gather. A invoke method is applied with the gather. So therefore, a invoke plus gather is nothing but multiple concurrent LLMs. So therefore, if anyone asks a question, invoke method versus a invoke method, this is the question here, interview question. Invoke method versus a invoke method, then a invoke method plus asynchronous ASYNCIO dot gather. What is the difference? So this is a nice question, interview question. When to use invoke method, when to use IA invoke method, when to use a invoke method with the asynchronous IO gather. Asynchronous IO gather. First one, invoke method we know well. Okay, one synchronous LLM model call. One synchronous model call. A invoke method is nothing but what? One asynchronous model call. One asynchronous model call. Model call or LLM call. Then what is this? This is nothing but multiple concurrent model calls. Therefore, when we want multiple concurrent model calls, then apply invoke method with a gather. So this is the exercise for it. It's just the same only. So what we did, we just we just did the invoke and try to gather the results with the task. That's it. That's it. So please remember this. This is one important interview question. Invoke versus a invoke versus a invoke with the asynchronous IO gather. Invoke means one, okay, one synchronous model call, one response. Asynchronous means one asynchronous model call and response. A invoke with gather means multiple concurrent model calls. Multiple concurrent model calls. When we have multiple concurrent model calls, obviously response is list. You need to iterate with the loops. That's why we are iterating with loops. So gather method, you can see. Gather method is giving the results. That results is nothing but multiple, right? So that's why concurrent. That's why list. That's why we are writing the loop and displaying it. That's about this one. This is how you are going to get the notes. That's all for today. If you have any questions, go ahead and ask. Else we are good for today and we'll continue tomorrow. Thank you.